for us.
Y'all, I have no idea if this is even going to record. I'm trying, but it's technical difficulties. Okay, so this is what? Well, I'm trying to record. So she asked, that's why I ahead of time. I'm recording right now. Yes. So y'all, we're going to finish up yesterday's stuff. This is the last problem. They give me this polynomial. Okay, and they want me to find the dimensions. They said, okay, this polynomial represents the volume of a box. What is volume? If you were trying to find the volume of something. It's the amount of space. What's the formula for it? Length times width times height.
No, it's like mass divided by volume.
Okay, so volume can be used for a lot of different formulas, But if I was trying to find the volume of a box, it's length times width times height. But what you're saying is probably volume is used in a lot of formulas. So anyway, I can see where that came from. All right, then they tell me that I know the length of the box is x plus 5. Okay, so if they give me the length is x plus 5, let's factor that out and let's find my other two. I need my width and my height. Does that kind of make sense? Yes. So when I factor it out, I'm dividing it because this looks very difficult to factor, like the old way, like a chapter ago. So let's write our -5. Remember when it's written like this, what do we have to use in the little box? The -5. Y'all remember that? I hope so. So I'm going to write my little -5 in my box.
Also, when do you know when to use your,
The actual number?
Yeah.
Okay, if they write find P of 3, use that number.
Okay.
If they write it as a factor, then you're saying, oh, then my 0 or my root is -5. Okay, so if they tell you find this, use that actual 3. Okay, but if they write it like this, then you're going to use the -5. Okay, make it the opposite. So what are my coefficients? They are 1, then what? 7, -38, and -240. I'm not missing anything, so I'm just going to write them all down. So then I bring down my 1, and what's -5 times 1? Then I add them together. Okay, then what's -5 times 2? Add them together. And I have no idea what this is. What's -5 times -48? Well, I just looked at the answer. So it's 240. Add them together, and that's my answer. Huh? It is a factor, but I told you it was going to be. So we should have had a remainder of 0, right? I said, this is one of your factors. If you didn't get a remainder of 0, well, you messed up. Now, let's write this polynomial. What would my new polynomial be?
1x squared.
1x squared, a 2x, and a -48. Well, how is that what would I do to find my length and my width? If this is my height or whatever, how would I make this into two things to find my length and my width? Thank you. Very good. Factor it. If I factor it, can I factor this? Have we learned ways to factor an x squared polynomial? Like this? Yes. X and x. And what are factors of -48? That would add up to 2? Very, 8 and -6, that's right. So x plus 8 and x minus 6. So these are my 3 factors. X plus 5, x plus 8, x minus 6. That is my length, my width, and my height. That would be what I would use to represent it.
That's terrible.
I thought y'all did really good on that. We need another one of those? Was that not kind of fun?
Is that our last? How many more problems we have?
Well, this was yesterday's lesson. We haven't done today's yet.
Wait, sorry.
I thought you were so busy this morning.
I am so busy. So, do we need one more of those?
No, you can skip it.
No, I mean, like, do we though? That was easy. Y'all could do that on your own. Okay. The only new thing is just factor one more time. Normally we don't do that, but if it's a length, width, and height one, a volume one, okay, then just factor it one more time.
Is there going to be anyone where we have to use, like, gray?
No, we don't have it that bad. No. Okay, today's lesson. You're welcome. I'm skipping some of the really, really difficult things because this is a hard chapter. We don't have enough time.
This is the hardest chapter in the world.
It is, and I'm skipping like the hardest parts of it too. You don't even know. There's stuff called rational root theorem, and it's basically you can find out how many roots there are. This is just a glimpse of what I didn't make you do. I just want you to appreciate me real quick. So there's this method that you could have learned, and you could look at coefficients, and then there's all these possibilities for roots, and then you have to try each of them. All these roots, a positive and a negative one, a positive and a negative two, all these fractions, and try and put them in here and see which ones work. But I'm not going to make you do that. Okay, we're going to skip that. And we're going to go to we're going to learn the conjugate root theorem. Okay, what is a conjugate? What is a conjugate? Okay, if I had, I'm sorry, it's got the toaster on it. No, we're not cooking anything. Like, for instance, if I had in a denominator 1 plus the square root of 2, and I needed to multiply by the conjugate, what would the conjugate be?
2. Wait, what? Is it negative 2?
What would make the square roots go away? It would be 1 minus the square root of 2. That's the conjugate. Y'all don't remember the conjugate? Where you keep the numbers the same, but you change the plus or minus sign. It makes the middle terms cancel out.
Trying to make those go to 0.
No. It's just trying to make like the square roots go away. There's something called the conjugate root theorem. Okay, and if you know one of the roots looks like this, then there's going to be a second root. It has the minus sign. Put your phones up if you have them out because that doesn't say anything about conjugates on there. Okay, so for instance, they say, all right, we have a quartic polynomial. What does quartic mean?
Like 4.
4 terms. And it has rational coefficients. That's important. So they tell us that square root of 2 and 1 plus I are roots. What are the other 2 roots? If it's quartic, they're going to have us 4 roots. What do you think? 1 minus I is one of them, and what's the other one going to be?
1.
I
have no idea.
Okay, if this is positive square root of 2, what do you think the other one's going to be? Negative square root of 2. Whenever it has like a square root or an I, if it's more complex like that, it's just the opposite. That's the conjugate root theorem. That's it. You don't even have to, well, we might do something in a second. But do y'all understand that? If 1 plus I is a root, then so is 1 minus I. Okay? That's just what their theorem says. Remember in geometry when they tell you, hey, here's a theorem, it just means this is a rule. Follow it. What if they have a cubic polynomial? How many roots do you think we're going to have? Cubic? 3. Okay. So they said, okay, if we have 3 minus 2i is a root, and 5 halves is a root. How many am I missing?
2. I'm at 1.
1. What do you think it's going to be?
3 plus.
3 plus 2i. If it's a complex, like if it has an I or a square root, then you have to do the opposite. You don't do anything that's just fine. 5 halves is just the number 5 halves. There's no...
If it's cubic, this must be 3.
3, yeah. That's kind of something that we skipped over some of the other rules.
So it's like a fraction or a whole number.
Yeah, if it's a fraction or a whole number, it's not necessarily the opposite of that. When it's complex. Do y'all want the air on?
No, there's something in there.
There's something in the air?
It's not in there. Shut up.
Okay. Next one. Let's see. This one says, okay, there's a 3rd degree polynomial with the following roots, and then they want us to write the polynomial. Okay? So here's my roots, -4 and 2i. So what do you think that my 3rd root's going to be?
-2i.
-2i. Now, if I write those roots in factored form, I don't know if y'all remember this, that would be x plus 4. Why is it plus 4?
The opposite.
Because it's opposite. What would my next one be? X minus 2i, and then what would my last one be?
Would it matter what order you put them in?
No, Now, but I highly, highly recommend, they don't want it in this form, they want us to write the polynomial in standard form. So what am I going to have to do? Distribute, FOIL it out. I highly recommend multiplying your conjugates because things will cancel out. Okay, because if one's a positive and one's a negative, middle terms will go away if they're conjugates. So I'll do FOIL method on this. This is the last thing we're learning for this whole semester. This right here, okay? So what is x times x times x? X squared. What is x times 2i? That's weird. How do they write that? 2ix. Yeah, we'll go with that. 2ix. But you'll see what happens in a second. What's negative 2i times x? Okay, and then what's negative 2i times times 2i? Negative 4i squared. Okay, so that's that one, and then we.
I squared mean?
What does an I squared mean?
Positive. No.
Negative 1. An I squared is negative 1. So let's simplify this one. I still have this little old x plus 4. Bring down my x squared. Those cancel out. That's why you always multiply your conjugates first. They're going to simplify. And what's negative 4 times negative 1?
4.
Positive 4. Okay, am I done?
No, you have to do it.
You have to FOIL it out again. Okay? So what's x times x squared?
X cubed.
X cubed. X times 4.
X.
4 times x.
4x.
And then 4 times 4. 16. But they would write it like this if it was multiple choice, and this is how I would write it too.
Wow. Okay.
At descending order. So all they gave you were these two roots, and they told you it was a third degree polynomial, so you knew you were going to have how many more roots? One more. So because third degree, we're going to do 3 roots. Does everybody get that? So you found your third root, then you write them like this, and you FOIL. That's the very end of the chapter. Well, for us. Okay, that's all we're going to do.
Yeah.
One more of those?
Yeah.
Yeah, just one more. Okay. Ooh, that one looks. That's kind of. I'm trying to think on that one. Let me see if I want it. It's a quartic. I'm not gonna do a quartic.
What's the one with the 5?
Quintic. Let me-
Linear is 2.
Huh?
Is it linear too?
No, linear has a 1 degree polynomial. Quadratic is 2.
What's
Huh?
a monomial?
Cubic is. Oh wait, I thought we were talking about degree. A monomial is 1 term, but if it has an x but no x squared, it's linear. If it has an x squared, it's quadratic. An x to the third is cubic. X to the fourth is quartic. X to the fifth is quintic. Okay, I'm probably gonna do
What's x squared?
quadratic. That was that whole last chapter. Okay, let's see. Find the additional roots. No. Here we go. This one's not bad. It just says, okay, write a polynomial function, and I know that the root is negative 10i. If I know a root is negative 10i, what's my other root? 10i. And so, I don't know anything else, so it must be a quadratic, right? How many roots do I have? 2. So, I would write my 2 roots as x plus 10i, and then what? X minus 10i. And then what do I do? FOIL. So this one's not as bad, right? I only have to FOIL 1 time. Since they're conjugates, what's going to happen? Middle terms will cancel out. Conjugate just means I have a plus sign and a minus sign. But the terms are the same, okay? What's x times x? And then do I need to write the minus 10i and the plus 10i? Yes, I will. Okay. What's x times negative 10i? Negative 10i x. What's 10i times x? Positive 10i x. If it was just me, I wouldn't have written that down. But it's not just me. Then what's 10 times negative 10?
10i squared.
And well, nope.
100.
It's negative 100 and then I squared. What happens to the middle terms? That's what should happen when we've got conjugates. X squared. What's negative 100 times negative 1? Plus 100. There you go. How is it?
It's all right.
It's all right. Do y'all need one more of those? How about I just put them on your study guide? Maybe I'll put a few of them for practice for tomorrow. So y'all, this is all we're doing for the rest of the semester. Study guide. So I'm not going to print out the new one just yet. Let me stop the video. Ooh, okay, I can't find it. Hold on.
Yeah, I found the study guide this morning.
I'm pretty sure that this video is not going to work. Where does it say stop record?